Just days ago, reports emerged that Meta is exploring a new business, renting out its AI computing power to external customers. Almost immediately, many investors interpreted that as a warning sign. If Meta was willing to rent out its AI infrastructure, did that mean the AI boom was already cooling off? AI-related stocks swung sharply as the market tried to make sense of the news. Then, less than 72 hours later, another report appeared. Meta was reportedly planning to invest billions of dollars in custom AI chips manufactured by Samsung. At first glance, these two headlines seem impossible to reconcile. If Meta has spare AI computing capacity, why is it still investing billions in building more AI hardware? Has Meta overbuilt its infrastructure? Or is the market misunderstanding what Meta is actually trying to achieve? Today, on Off Script, we're going beyond the headlines to uncover the strategy connecting these seemingly contradictory decisions and why understanding it changes the way we think about the future of AI infrastructure. To understand why these two headlines aren't actually contradictory, we first need to understand the scale of Meta's AI infrastructure. Over the past few years, Meta has quietly built one of the largest AI computing clusters in the world. Industry analysts estimate that the company now operates the equivalent of around 600,000 NVIDIA H100 class GPUs, a level of computing power matched by only a handful of hyperscale technology companies. These aren't gaming graphics cards. They're specialized AI accelerators designed to train some of the world's most advanced artificial intelligence models, including Meta's Llama family of large language models. Each one costs tens of thousands of dollars, consumes roughly 700 watts of power under load, and represents a massive investment in both hardware and electricity. Taken together, Meta's AI infrastructure represents tens of billions of dollars in capital investment before a single AI model even begins generating value. But here's the assumption many people get wrong. Owning a massive AI cluster doesn't mean every GPU is busy every second of every day. That's simply not how hyperscale data centers operate. Training frontier AI models happens in large bursts. Engineers launch massive training jobs that can run for weeks or even months. But once those jobs finish, the infrastructure doesn't immediately disappear into the next project. There are periods of lower utilization while new models are prepared, experiments are designed, or systems are reconfigured. The challenge isn't building enough computing power. It's making sure that expensive computing power stays productive as much of the time as possible. This is where Meta saw an opportunity. Rather than letting valuable computing resources sit underutilized between major workloads, why not make them available to other companies? If that spare capacity can be rented out during quieter periods, it transforms a fixed cost into a new source of revenue, without reducing Meta's ability to train its own models when demand returns. Yet many investors interpreted the news very differently. To them, renting out AI compute sounded like a sign that demand for GPUs was slowing. But that conclusion overlooks a much more important distinction. There's a difference between having unused capacity today and needing more computing power tomorrow. That brings us to the second headline. Other reports suggested the company was preparing to invest billions of dollars in custom AI chips manufactured by Samsung. If Meta was looking to monetize spare computing resources, why spend even more money expanding its AI hardware? The answer is that these two decisions solve two completely different problems. Renting out and used GPU capacity is a short-term strategy to improve the efficiency of existing infrastructure. Investing in custom silicon is a long-term strategy to reduce the cost of running AI at an enormous scale. To understand that long-term strategy, we need to look at how AI actually consumes computing power. Not all AI workloads are the same. Broadly speaking, modern AI operates in two very different phases: training and inference. Training is the process of teaching a model how to solve problems. It requires enormous amounts of computing power, runs for weeks or even months, and is where NVIDIA's most powerful GPUs excel. Inference, on the other hand, happens after the model has already been trained. Every time Meta recommends a reel, ranks your Instagram feed, answers a question through Meta AI, or helps generate content, the model is performing inference. These requests may be individually small, but they happen billions of times every single day. And that's where the economics begin to change. This is why Meta's custom AI chips matter. The company isn't trying to replace NVIDIA. It's trying to use the right tool for the right job. Training the next generation of AI models will continue to require some of the most powerful GPUs in the world. But serving billions of AI requests every day is a completely different challenge. At that scale, even small improvements in efficiency translate into enormous savings. That's where custom silicon comes in. Rather than relying on general-purpose AI accelerators for every workload, Meta has been developing its own chips, known as the Meta Training and Inference Accelerator, or MTI. These chips are designed for the repetitive, high-volume inference tasks that power products like Facebook, Instagram, and Meta AI. They may not match NVIDIA's flagship GPUs in raw performance, but they don't need to. Their job is different. Deliver the right level of performance at a much lower cost and with far greater energy efficiency. So that's the picture. Meta rents out the spare capacity to squeeze more value from what it already has, and it goes to Samsung to build custom silicon for what's coming next. 2 moves, 1 logic. If we only read headlines, it's easy to mistake efficiency for weakness. But when we understand the underlying economics, a very different picture begins to emerge. That's what Off-Script is all about. Every week, we'll go beyond the headlines to understand the technology, the business strategy, and the economic forces shaping the future. Thanks for watching. And until next time, stay curious.